Today we're going to discuss power and efficiency. Power as a rate of energy transfer. Power is a rate of energy usage, and so has an equation. So power equals to work done per unit time, or power equals to energy per unit time. And formula, we see that power has a unit of energy, which is joule, per time, which is second. So joule per second, which are known as watt. Let's take a look at the example. How much energy does a 100-watt bulb consume in 1 day? The unit of time is in second. So power equals to energy over time. The question asking the energy, which is equals to energy equals to power times time. We rearrange the equation, and energy equals to power times time. Power is 100 watt, and the time is 24 hour. We need to convert that into SI units. That is 24 times 1 hour is 60 minutes, and 1 minute is 60 seconds. So 24 times 60 times 60, that gives us second. 8,640,000 joule. So don't leave lights on in unoccupied rooms, and that's a lot of energy being consumed. Power equals to force times the velocity times cosine theta. We derive this equation. Since power equals to energy over time, we can begin by rewriting the energy as work. So work done equals to force times the distance moved in the direction of the force, which is F times S times cosine theta. We learned this in our previous lesson. So power equals to energy over time, which is work over time, and we substitute work done, which is force times the distance moved in the direction of the force, which is force times the distance moved cosine theta over t, and rearrange distance over time, and distance over time gives us speed. And the physics data booklet has only P equals to F. Neon, the horse walking at 1.75 meter per second, is drawing a barge having a drag force of 493 Newton along the river Lee as shown. The angle the draw rope makes with the velocity of the barge is 30 degrees. So let's take a look at velocity moving. So the barge is moving forward, and the horse applying force in this direction, and the angle between them is 30 degrees. Find a rate at which Neon is expanding energy. Let's visualize that two directions. So velocity F here, and the direction of the barge move is this direction, and we need to be careful about the direction actually. So that's the angle. Earlier we learned work done, which is a force times the distance in the direction of the force. Similarly, in the power, it is force times the velocity in the direction of the velocity. So in the direction here is F cosine theta. So now we have P equals to F times cosine theta times velocity, which is F v cosine theta. Force applied is 493 Newton, velocity is 1.75 meter per second, and cosine 30 degrees. That gives us 747 watt. The drag force of a moving object is approximately proportional to the square of the velocity. Find the ratio of the energy rate of a car traveling at 50 miles per hour to that of the same car traveling at 25 miles per hour. And the question asking to find the ratio of the energy rate. The energy rate is a power, and we learned that power equals to force times the velocity. Since the question said that the drag force of a moving object is approximately proportional to the square of the velocity. So which means force is proportional to velocity squared, and that gives us force equals to k constant v squared for some k. And we plug the force into our power equation, we get kv squared times v, and that gives us k times v cubed. Then P50, our P25 equals to, as it is proportional, k times 50 cube, our k times 25 cube. That k's cancel out. 50 our 25, whole thing is cubed. That gives us 2 cubed, and that is 8. It takes 8 times as much gas just to overcome air resistance if you double your speed. Efficiency is a ratio of the output power to input power, or efficiency is the output energy over input energy. Conversion of coal into electricity is through the following process. Coal burns to heat up water to steam. The steam turns a turbine. The turbine turns a generator, which produces electricity. Suppose a usable electricity from such a power plant is 125 megawatt, while the chemical energy of the coal is 690 megawatt. Find the efficiency of the plant. Here we need to pay attention to the which one is the input power and which one is the output power. Since the output is electricity, then our output power is 125 megawatt, and input power is the chemical energy, in this case coal, burning of coal we use, which is 690 megawatt. So efficiency is output power over input power, and output power is 125 megawatt and input power is 690 megawatt, and megawatts cancel out. That gives us 0.18 or 18%. So efficiency is just 18%. A system consists of bicycle and cyclist traveling a constant velocity along a horizontal road. State the value of a net force acting on a cyclist. Bicycle and cyclist traveling at a constant velocity, which means the net force acting on it is 0. Since the system is traveling constant velocity, then the acceleration is 0. If the acceleration is 0, based on F equal to ma, the net force acting on 0. On a diagram, draw labeled arrows to represent the vertical forces acting on the bicycle. So we have the weight downward and force downwards on pedals. We have normal reaction force from the front wheel, and we also have a normal reaction force from the back wheel. With reference to horizontal force acting on the system, explain why the system is traveling at a constant velocity. We know that the system is traveling constant velocity, but the question is why the system is traveling at a constant velocity with reference to horizontal forcing acting on it. Let's take a look at the horizontal forcing acting on it. Forward force is a thrust, and backward force is drag force. So the drag force equals to thrust. That means net force equals to 0, which is drag force minus a thrust. That is 0. Which means the acceleration is 0. That implies the system is traveling at a constant velocity. So total resistive force acting on a system is 40 Newton and its speed is 8 meters per second. Calculate the useful power output of the cyclist. The system is traveling with a constant speed, which means the net force equals to 0. Drag force is given, which is 40 Newton. As we know, the net force equals to 0, so drag force equals to thrust. That's also 40 Newton. And based on the formula, power equals to F times velocity. Force is 40 Newton and velocity is 8. That gives us 320 watt. See, the cyclist stop pedaling and the system comes to rest. The total mass of the system is 70 kilogram. Calculate the magnitude of the initial acceleration of the system. As a cyclist stop pedaling, the net force acting on the system is only the drag force. And we know that F equals to ma, and the net force is the drag force. So acceleration equals to drag force over mass, and the drag force is 40 Newton. Mass is 70 kilogram. That gives us 0.57 meter per second. Estimate the distance taken by the system to come to rest from the time cyclists stop pedaling. Work energy theorem, which is work done equals to change in kinetic energy. And we know work done is the force times the distance moved in the direction of the force, which is Fs times cosine theta equals to final kinetic energy minus initial kinetic energy. Final kinetic energy is 0 as the system stops. So we substitute force applied is 40 Newton. Distance moved is we are looking for, and since the direction of the friction force and the distance moved is opposite direction, they are anti-parallel. That the distance moved is forward, but the friction force is opposite direction. So the angle between the friction force and the distance moved is 180 degree. So that's cosine 180 degree equals to minus 1 over 2 times mass is 70 times initial velocity is 8. So 8 squared. That gives us the 56 meter. State and explain one reason why your answer to CII is only an estimate. The cyclist stop pedaling and the system comes to rest eventually, which means the velocity decreases over time. So air resistance drops as the speed decreases. And we know drag force is proportional to velocity squared. So velocity decrease means drag force decrease, which means air resistance decrease as speed decrease. That means that distance traveled will be far.